individuals, the families, the members, and all everything good. Teach somebody else, man.
You know, I saw it here and I don't have one.
I see, there you go. All right. When we say molecular geometries, what do we think we mean?
Geometries.
What does that mean?
How
Shapes.
it looks. Okay.
Okay? Okay? So now, molecular shapes has to do with our bonding pairs as well as our non-bonding or lone pairs.
Yep. This is true.
Yeah, I think so too.
Yeah.
Okay? What we need to know is that when electrons, even if they're in a bond, when they come near each other, they're going to repel each other. Okay? So your electrons in your bond has to situate themselves at a particular angle that is going to minimize the amount of repulsion that they feel. This is what gives you your molecular shape. Alright? So our shapes examples are linear, bent, trigonal planar, trigonal pyramidal, or T-shaped. These are some of the type of shapes that we will have. Okay? And I will give you a breakdown on how we're going to classify our shapes. The way I like to teach it, I like to teach it as families and members. Okay? Now, the first thing we need to know is electron domains. Electron domains or bonding arms. Electron domains are simply what is bound around your central atom. When you're thinking about electron domains or bonding arms, if you see a double or a triple bond, that is going to count as one. This is chapter 9. You good? Yeah. Okay? Oh! Give me 1 second. What happened? I have some other stuff. Oh.
How much that cost?
Bye.
Oh, God. You trying to share though?
Good?
I'm sharing.
All right. So for electron domains, if you have double or triple bonds, that counts as one thing, one bonding arm, one electron domain. All right. So here, if you have a lone pair as well, a lone pair counts as one electron domain. It counts as a bonding arm as well. Okay? So if you have a single bond, that's an electron domain. If you have a double or triple bond, each one is one electron domain. If you have a lone pair, that's also one electron domain. Okay? Where's my central atom in this compound?
A.
A. How many bonding arms do I have in this compound?
4.
Why you say 3?
You count the double bond as one.
Uh-huh.
Two other ones.
Okay. And what else? Do you have anything else there?
Huh?
You have anything else bonded there? Well, you started finding it. Oh, that's true too. So how much is it?
But you said bond, you didn't say how much.
But I never said on there.
4.
You have 4. You have 2 single bonds to B's. You have a double bond to B, and you have your lone pair here. So there are 4 bonding arms, 4 electron domains. Okay? So now we have Vesper. Vesper is the valence shell electron pair repulsion theory. All that is how the electrons in the bonds are going to situate themselves. That's all that is. You got a long name to tell you that the electrons are going to position themselves at an angle that is going to minimize the repulsion. That's all that means. Okay? Now, if you have 4 bonding arms around your central atom, that gives you a tetrahedral shape. Okay? The bond angles for all of your carbon, what's the name of this?
Carbon perchlorate, chloride.
Wow, really?
Tetrachloride.
Put it together. Thank you very much. Carbon tetrachloride. Okay?
Always be
Yeah,
playing,
Brain.
All right. So now all of your carbon, your chlorine bond is going to angle themselves at 109.5 degrees away from each other. This is the angle that will give you the minimum amount of repulsion.
What's the angle?
109.5. So here, molecular shapes and bond angles. Yes, you must remember your bond angles. If you have linear, you have 2 things bonding around the central atom, that is 180 degrees away from each other. If you have trigonal planar has 3 bonding arms, the angle is 120, thank you. Tetrahedral, we have 4 bonding arms, 109.5. We have trigonal bipyramidal, that is a flat face, trigonal planar on the plane, and then your linear on either end. Your trigonal planar part, that's 120. Your linear to your trigonal planar, that's 90 degrees. Now you have octahedral. Octahedral has 6 things bound around the central atom. Each of the angles are 90 degrees away from each other. That is on the slides.
So we have to know all of those.
You know you got all of them because there are others
These plus
too.
the vent, right?
There
Or
are
is that
others
gonna
in
be a
there.
part of
There's
it?
others in there. Yeah. You'll learn it based on families and members. Don't worry, we'll get there. Okay? So now, non-bonding pairs and bonding angles, right? Your non-bonding pairs, so your lone pairs. Let's take your bonded pairs. How is the electron density situated when you have a bonded pair?
It's closer to 1.
Closer to 1.
Electron density.
The electron density, it's shared or it's localized in between your 2 nuclei. But your non-bonding pair is just spread out. Okay? It has nobody watching, it's home by itself, it cock up. Alright? So that means if you have a lone pair, what's going to happen? It's going to now spread out. What's going to happen to the other bonds, with other angles? It's going to come closer together, it's going to shrink. Right? So here, if you have 4 things bound around the central atom, you're in the tetrahedral family. All of these are in the tetrahedral family because you have 4 things bound around the central atom. But their members are different, therefore their angles are different. So here, full on tetrahedral, 4 things bound around, 4 atoms bound around the central atom. Your angle would be 109.5. If you remove one of your bonded atoms and you make that into a lone pair, the lone pair is going to spread out. And therefore, the angles, everyone is going to rush away from the lone pair and the angle is going to shrink. If you remove 2 atoms and you make both of them lone pair, the lone pair is going to spread out even more. And the angle is going to shrink even more to 104.5. 104.5. Do we get that? And how the lone pair affects the bond
You
angles?
said this is all in the slides, right? That all of this is in the slides?
This is in the slides.
That one's in the slide?
I believe so.
I don't think
It was
so.
on the last list.
It wasn't? You
Oh
sure?
yeah, it is. It's just like it's not
It's
in order.
small. It's not in order. Not in order of the way I'm putting it together.
Okay.
Alright. Multiple bonds. How does multiple bonds affect your bond angles? So now, if you have a single bond compared to a double bond, how does that now affect the electron density? No stronger. Higher. Which one though? Single, double. Who's has the high electron density? Your double bond. Your double bond has a greater electron density around it. So now what does that again mean for the angles?
Smaller.
The angle will get smaller. So here, for example, this, you have 3 atoms bound around the central atom. This puts you in the trigonal planar family. Alright? The angles for your trigonal planar is 120. But because you have this double bond here, your 2 chlorines is going to run away from the excess electron density, and therefore this angle is going to shrink and this angle will increase.
So this decreases on
No. This one is going to increase because the chlorines are running away from the double bond. And the carbon-chlorine angle will decrease because it's coming towards each other. But even though your double bonds will affect your bond angles, we're going to keep all the trigonal planar family at 120 degrees. Okay? But just be aware that the angles will change because your double bond has a greater electron density around it. Okay? Alright. Vesper. How do we predict the shape of a molecule using Vesper? The first and foremost thing you must do is draw my Lewis structure. Once you have drawn my Lewis structure, then you're going to count how many electron domains you have. That is going to give you the family. Once you count how many electron domains, you're going to pick how many bonding pairs you have, how many non-bonding pairs you have, and that is going to identify for you the member that you are. So here, what's the name of this?
And then,
Who?
It's NH3.
ammonia.
Ammonia. Okay? Now, you draw the Lewis structure for ammonia.
Eon or
Okay. Okay? Nyum
NH4
is NH4.
Gotcha.
plus.
Right? Plus, yes. Alright? So now, when you have your Lewis structure drawn, this is now going to translate into your overall structure. There are 4 things bound around the central atom. That puts you in the tetrahedral family. But you are not the tetrahedral member because you have a lone pair. So now, you have to take into consideration who is the other members in the tetrahedral family. This puts you, because you have a lone pair, you now are turned into trigonal pyramidal. So you have the trigonal, and the lone pair makes you look like you have a pyramid. Did we get that? Okay. Alright, so again, tetrahedral family. If you have 4 atoms bound around the central atom, that
No
puts
lone
you, huh?
No, I was just saying with no lone pairs.
No lone pairs. That puts you in the tetrahedral family. That also makes you the tetrahedral member. If you remove 1 atom, make it into a lone pair, that makes you your trigonal pyramidal. If you remove 2 atoms and make them 2 lone pairs, that makes you bent. Do we get that? Okay.
And 2 from the tetrahedral, right? Not from a trigon.
No, that's something different. That's a different scenario. Now let's get deeper into our families. Okay? We have our linear. Linear is free, single, and disengaged. Living the bachelor life. There's only linear in its family. Linear has two things bound around the central atom only. Okay? Then you have the trigonal planar family. The trigonal planar has three things bound around the central atom. Now, inside the trigonal planar family, you have two members. The trigonal planar, who is the head of the household, that has three atoms bound around the central atom. Then you have the member bent. Bent has one lone pair and two bonded pairs. Do we get that? Now we have the tetrahedral family. Tetrahedral family has four things bound around the central atom. The tetrahedral family has three members. Tetrahedral, the head of the household, that has all bonded atoms around the central atom. Then you have the member trigonal pyramidal with one lone pair. Then you have bent with two lone pairs. Now, how are we going to distinguish between bent from the tetrahedral family versus bent from the trigonal planar family? How are we going to tell the difference?
One
The lone pair.
The number of lone pairs. Your trigonal planar family has one lone pairs with a bond angle of 120. Bent in your tetrahedral family has two lone pairs with a bond angle of 104.5.
So it's
104.5.
you gotta say that
Yes.
in the exam.
Yes.
So why on the paper is at 105?
What paper? In the book?
In the lab
The
report.
lab.
Lab book.
Yeah, it's
That's
one
how-
five.
That's
Well,
how Dr. Miller made the book.
Why does every professor have a different number?
These numbers I'm getting straight from the book. I don't know
So
what
you want it on this
From-
exam?
104.5.
Gotcha.
Somebody's 104.
Now, in your trigonal bipyramidal family, you have two areas where you can have your positions, okay? The one that looks like a linear, that is called your axial position. The one that looks like your trigonal planar, that's your equatorial position, okay? If you are going to lose an electron, lose your atom to make your lone pair, you're going to lose it from the trigonal pyramidal side, the trigonal planar side, sorry. This is because it's lowering energy. You'll learn more about that when you get further up. Just trust me on this. You don't lose it here. It's easier. It's easier to pull off one of these atoms than it is to pull off that atom.
Is that called the equatorial side?
The equatorial side.
The equatorial one is the one that's horizontal.
Yes. Okay? So now wait, what's the name of this?
Sulfur.
Fluoride. Tetrafluoride.
Tetrafluoride.
Sulfur tetrafluoride. Very good.
I'm gonna say that.
Now, if we remove an atom from your sulfur and replace it with a lone pair, thank you. What are the bond angles for your trigonal bipyramidal? What is your trigonal looks like?
Trigonal bipyramidal.
Yes, what's the angles there?
Did you say 120?
120 and then 90 to each of them, all right? So now if we look here, we see the next two equatorial positions has a bond angle of 116, and the one that looks like a linear has a bond angle of 186. Can we explain why?
Because the 116 is pushing closer together, opening up the 180. So instead of it being a perfect line of 180, it's
There you go. Your lone pair is spreading out. Because it's spreading out, everything is being pushed back. If everything is being pushed back, your 180 angle will now increase and your 120 will decrease. Do we get that? Okay. Now, in the trigonal bipyramidal family, you have 5 things bound around the central atom, and you have 4 members in your family. The head of the household, trigonal bipyramidal, where all atoms are bound. If you remove 1 lone pair, you end up with a seesaw. If you remove 2 lone pairs, you end up with T-shaped. If you remove 3 lone pairs, you end up with linear. Now, how do we distinguish between linear for trigonal bipyramidal and the linear family itself? The number of lone pairs. In the linear family, there is no lone pairs. But the trigonal bipyramidal family that has linear as a member has 3 lone pairs. Okay? Last one.
Professor?
Yes.
We have to know the angles or?
No, not these. No.
Oh, we don't have to know these
The
values?
angles, not the angles, but you need to know the shapes.
Up to
So
which
how
point
would
do we
you
have
say?
to memorize the angles? Up to which?
Tetrahedral.
Bonded pairs or something?
You gotta know everything for tetrahedral.
Tetrahedral and back. You
Yeah.
just gotta know all the damn values.
Yes.
Quick question, how would you name it? Like, so it's trigonal,
Trigonal?
trigonal bipyramidal?
Yes.
And in the case of what, it'll ask about linear or something, like why would it?
No, look, this is linear.
I know.
If trigonal bipyramidal has 3 lone pairs, it's coming up to be linear. It would ask you, what is the geometry for a particular compound? It can give you X and 2.
But would you not label it as a bipyramid, a trigonal bipyramid?
No, you would not. That's the family.
Oh,
But you also need to tell me the member. So you'll have both of them together. So you will tell me trigonal bipyramidal linear.
got
Trigonal bipyramidal seesaw.
it.
Okay, that's the family and the member. Last one. Octahedral. Octahedral has 6 things bound around the central atom. We have 3 members in the octahedral family. Octahedral, head of the household. If you remove one atom to make a lone pair, you have square pyramidal. If you remove 2, no seesaw. We have square planar. Did we get that? Okay. Questions? Use VESPR to predict the molecular geometry and the bond angle of the following.
That's 18 electrons in all 3, right?
I think so.
Huh? Say it again.
So, I want the family, I want the member, and I want my bond angle.
Oh, it's in.
If the lone pairs are bonded not on the central atom, it don't matter, right?
It don't matter. All that matters is your central atom. Good job.
So
Who's next?
if you write the resonance, right, is that wrong?
Why? Why would you write the resonance?
Like what if you like not check and just write the resonance?
What do you mean check? What are we checking?
Cause 03, I think I did the resonance.
It'll still be the same thing though. Both fluid structures look the same.
Can I just try the next one? I
So
don't
you
know.
don't plan on,
Job.
I mean.
Oh no, you wrote the wrong. That's the wrong thing. No, that's not even a resonance. That's wrong. How many electrons? Yeah, no, that's wrong. In fact, that's all the way wrong. Not even halfway, but all the way wrong. Follow my procedures. Well, how did I teach you how to write the Lewis structure?
Oh, to check the focal charges.
No, before that. Start that one, start over from the top. Oh, what's the name of this one?
Trigonal.
Ooh!
Nope.
Tin 3 chloride.
Thank you.
Oh, the names.
Also, in the family picture, no, wait, no, it's just head and vent.
Yeah. Seven times three is 21 plus 5. No ma'am, no ma'am, no ma'am. You're missing something. How many electrons do you have to play with?
28.
Ooh. Whoa. How much is chlorine coming with?
7.
How many chlorines do you have?
3, but then it's the minus.
Right.
So do you not add
Yes, you add that. However, how much does tin come in with?
4?
Okay, so how much is that?
4 and 21.
Yes.
But I thought you did the 8 initially. That's why I'm asking.
What 8?
You're adding an electron.
Okay, so let's go back again. How much does chlorine come in with?
7.
How many chlorines do you have?
3, that's 21.
21. How much does tin come in with?
4.
So add that.
So then I'll have,
Add that.
okay.
What is that? 21 plus 4.
It's 24, 20, 25.
Right. Plus your minus.
It's 26. Okay. That's fine.
Okay, so erase all of your dots. Erase your lines as well. Okay? So now, how many electrons do you have to play with?
26.
26. How many electrons have you just used up?
6.
So how much do you have left over? Write that down. No, not there. Write down 20. That's how much you have left to play with.
Yeah.
Right? So now, what's the next step that you do? Fill up the octet of the outers. So fill up the octet for the outer ones.
This is 16.
Keep going. Keep going.
20. That's 20.
No. You're adding so wrong.
This is 16.
No, that is not 16.
This is 8 and that's 8.
No, don't do that. You're working, remember, you already counted your lines. Your lines are no longer involved in
Well,
this now.
I'm just putting it together.
No, don't do that because you're confusing yourself.
I'm
Don't roll your eyes at me.
Well, I'm not rolling my eyes at you. I'm not confusing myself. Because I know I'm thinking of this as 16, and then I'm adding this as 18, and then I have 2 more to add, so I have 2 more electrons.
No.
Okay, so where are you adding it?
I was gonna put it with the other part.
And that's it? Are you done there?
Yeah.
And that is wrong. This is what I'm trying to tell you. This is wrong.
I know, because this is not. I told you I wasn't done. I just said I was gonna do it on the board.
No, what I'm telling you, the way you're doing it is wrong.
And I agree.
Okay, so then let me help you.
Okay, well you're just like coming at me.
No, I'm not. Like I'm trying to help you, but you're not letting me.
Okay, I have 2 more that I have to use.
No, you have more than 2 more.
Okay.
Okay, so come, erase the dots again. Just focus on the dots. How many electrons do you have after you've written your lines?
No, I have 23.
No.
20.
You have 20 left, okay? How much does the chlorine on your left-hand side need to complete its octet?
6.
So add 6. How much do you have left now from your 20?
14.
So write down that 14. Now, how much does the chlorine on your right need?
6.
So write down, put in the 6. How much do you have left from your 14? Write down the 8. How much does the chlorine on the bottom need?
It needs 6.
So write down the 6. How much do you have left from your 8? So where does that 2 go? There you go.
Okay. Alright, so then this would be a,
No.
you want me to put the family first, right?
Yes.
Family first, isn't that a trigonal pyramid?
No.
No, it's not.
That's not the family, that's a member.
I thought it's a chart, are the families?
How many things you have bound around the central atom?
3. 4.
4. What families does that put you in?
Tetrahedral.
Tetrahedral. Now what member are you?
Oh, it's a trigonal.
And what's the bond angle? There you go. That's what I got to you. So, next one. What's the name of this one?
That's not tin chloride, the one before, because tin isn't a transition metal. So,
Tin is not an alkali earth.
I thought you only say tin chloride is the metal and the transition.
You can say tin chloride.
For a metal as well, plants?
It's not really a metal.
Do they just have it in the wrong spot?
It's not in the wrong spot. Remember, it's angled.
This is just
I might say.
Yeah. Yes. So what's the name of this one?
Selenium.
Selenium dichloride.
Very good. Selenium dichloride. What's my family member and angle? That's what I got. Last one. What's the name of this? Carbonate. What's my family, my member, and my bond angle?
Oh, isn't it just they had
Which is trigonoplanar. That's what I got you. Did we get that? Okay. Now, if you have larger molecules, you could ultimately figure out what is the geometry around each individual's.
Sorry, 1 second. Can you go back to that? Why was that one picture you know?
Which one? This one?
Yeah,
Did you draw the Lewis structure?
yeah. But it says if there's 4,
How many does it have?
isn't it 2?
No,
There's
ma'am.
2 lone pairs on selenium.
There's 2 lone pairs on selenium.
So would it be wrong if you just wrote bent? Bent 1 4?
Oh, because there's 2 on each side? Well, I'm confused as to what's that.
So come, draw it for me. It depends on what they're asking you for. They can ask you for the molecular geometry. That's the family. They can ask you for the molecular shape. That's the member.
So that's the bent.
Right.
You have 28 flavor, right?
I don't know. I'm sure I play with.
What's that?
So carbon. Can I ask a question? So carbonate, right? That's 4, 18 plus 4, 22, and it's 2 minus. What does that say?
2 minus. That's 2 minus.
2 minus, so it's 24.
Mhm.
That's good.
Don't put them over here?
Ah,
Oh.
remember that? No, we need more than that.
1 more pair.
There you go.
Why would I put them here?
Because what is that the procedure?
Oh, because you need 7 for.
You needed 6 more for chlorine to be happy. 1, 2, 3, 4, 5, 6, 7, 8. Remember, there's 2 electrons in here, no? So that's 2, 4, 6, 8. Chlorine is happy. 2, 4, 6, 8. Chlorine is happy.
Is carbon one of
So-
those?
So you get how it's tetrahedral?
No.
How many things are bonded around selenium? 4. What family does that put you in?
Okay, that's what.
Tetrahedral.
Okay, just.
How
So
much?
it's about how much is bonded on this
Yes.
one? Okay.
So this would be the carbon. And one, oh, that's why it's so tricky.
Excuse me? Yeah. The molecular geometry you said is the member? Excuse me. That's the family. Molecular geometry is the family. The molecular shape is the member. So they can either ask you for the molecular geometry or the molecular shape, or both.